Hi, and welcome to another episode of the Data Standard. And we have a cool guest today, a new friend of mine, Tim. And Tim and I met via LinkedIn, and he has this incredible headline, Squeeze the juice out of data science. And when I see a headline like that, you know that person's going to be a guest. So with that, Tim, I thought we kind of talk about some of the things that you're seeing and some of the juice that you've squeezed out of this lemon. So Tim, why don't we start with, what are you working on? What are you building?
Yeah, thanks for having me on this show, Darren. I'm flattered by your kind impression of me just based on a couple words. So I'm involved in two projects right now. My main project is my company dcyd, dcyd. You can find it at dcyd.io.
Well, so dcyd.io.
Yeah. And it's fun to think out about what some acronyms are for dcyd. Like double click on your deployments, dcyd. That's one. You can check out my website and find a few more. The premise of dcyd is that even after a decade of awesome progress in data science, there's still a gaping hole at the tail end. After something goes into production and machines are now making decisions for us, we have very little introspection into the success of those decisions. So much effort is put into training a model and then deploying a model. Deploying a model can take a year or something like that, depending on how advanced your company is. We're finally getting past that, and so now we can click to deploy. But now the big hole is, how do I know that it's still performing in production the way I hoped? Because there's many things that can go wrong. Your populations can change. You open in new markets. Seasons change. Those would be natural evolutions of your model. But also you can have data streams that break. How many times have you checked a model 6 months later and seen that, oh my goodness, we've been passing null values in for this? Or what used to be an integer is now a double or a non-integer or a string even, and our model doesn't know how to handle that, so it breaks, or it just goes to the default bucket, like classify, I don't know what's going on, put return default value 5 or something like that. And I've been there too many times, and it's time for software to come in and prevent this from happening.
So, on that, I think it's good for the audience to hear, an example, right? So, a use case. Can you share what you're thinking as like an ideal use case?
Sure. So, first of all, there's the accountability issue. After something goes into production, it's regarded as finished and people move on. But even if people want to should recognize that it's not finished, you don't have clear accountability for who owns this. So on one hand, data scientists who developed the model, maybe on their laptop, they don't feel accountable for the production performance because they're not even equipped to look for the logs or to fix real-time feature engineering or to maintain the microservice that's hosting everything. That's not their job. An engineer doesn't feel equipped to step in and own this because they don't know they're not statisticians who understand when this thing is, quote, broken. For them, broken is we're getting 404 errors from our HTTP endpoints, not, oh, there was a 30% increase in the median value of some feature. And a PM who really owns the KPI that justifies the existence of the model in the first place, they're not equipped to do this because they can't even see, they don't have the visibility to see that something is broken. They're just looking at their high-level KPI, which masks all of the different decisions that go into moving that KPI. Now, more specifically on a particular model, here's a fun example of a change that would break a model. I've built some pricing models, pricing recommendation systems, both for Lyft and also for Turo. And as you can imagine, if you're doing dynamic pricing, one of the inputs into your work is what is the supply and what is the demand? Because from an economic point of view, if demand shoots way up, you can justify having higher prices. Of course, you're justifying high prices because you're really trying to increase profits or revenue or something like that. Or you're just trying to make sure there's always some product left over for people who are willing to pay. So one of my signals is demand. Let's think about that. Let's double click on that. Demand is often a regional a regional number. It's not demand in the entire world. It's demand within San Francisco or demand within Los Angeles or something like that. So at some point, you might have demand for San Francisco equals 100. And that number came from looking at the number of logins in the last 5 hours or something like that. Now, San Francisco, do I mean just the city? Do I mean the entire Bay Area? In the first iteration, when somebody comes up with a definition of demand, they might be counting all of the clicks from the entire Bay Area. Now, a year later, the marketing department, say, wants to refine the regions. And they say, actually, San Francisco should just be really the city limits. And we're going to have a separate region for East Bay and a separate one for San Jose and maybe a separate region for the peninsula itself. So what's this going to do to your measurement of demand? Well, it's roughly going to quarter it. So whereas demand used to be 100 on a typical day, now demand is 25 on a typical day because I'm just looking at 1/4 of the area. Now, here's the trouble. The model that I trained understood that 100 was a reasonable number. And it was trained to, my pricing algorithm had learned that actually if there's 100 demand, we should be charging 20 bucks. If there's ever only 25 units of demand, we should be dropping prices because there's insufficient demand. So now comes that's the breaking change. Somebody changed the definition of demand without letting me, the model builder, retrain my model as a result. So what's going on is now my model is being fed a bunch of 25s. It thinks, ooh, demand is nothing. I'm going to slash all my prices. So there's a break right there.
So now on that break, with your technology, is it an easy lift to install? Is this a super complicated?
Yeah.
What are your thoughts?
How do I do this? Right. So I want to zoom out a little bit and talk about the structure of the problem again, and then I'll show how my solution works.
Love it.
When people talk about data scientists doing machine learning, that's only one piece of what they do, and this has been said many times, many ways. But in my view, a data scientist, a quote, algorithmic data scientist, is not just predicting, building predictive models, they're actually making decisions. An example would be, the product needs to know, hey, what price should I charge? And the data scientist can build a system that says you should charge 20 bucks, you should charge 30 bucks, depending on everything it's reading about the universe and depending on what it's trying to optimize for. Another time a data science team makes a decision is the product needs to know, hey, should I let this transaction take place? And here's a bit of context. This transaction is coming from Russia. It's 2 in the morning in Russia, and this credit card has been used, well, it's a brand new credit card. So your fraud model might learn something about that. But the ultimate decision is, this is a 99% chance of fraud, so you might want to block this transaction. Again, yes, under the hood, there was a prediction. It said, what's the likelihood that this was fraud? But on top of that decision, there was on top of that prediction, there was a decision that was being made. Because I predict this, therefore I decide that. And the pricing one also has that one. Because I think there's a 50% chance that somebody's going to purchase this product at $20, and because there's a smaller expected return at any other price, therefore I decide we're going to charge $20. And there is a prediction about what would happen if I charge 20 bucks, what would happen if I charge 30 bucks. Okay, between those two, I'm trying to optimize for revenue, therefore you should use this price. So, and pricing and fraud detection are only 2 times. There's also, the product might ask, hey, I have a bunch of products, in what order should I list them? I'm an ad bidding company. How much should I bid on this or that ad impression? I'm a marketing company. How much money should I allocate for this campaign versus that campaign? Or I'm Lyft or Uber. Which driver should I match to which passenger? So again, it's decision making. Yes, the decision itself might consult a predictive model under the hood, but zooming out again, I just wanted to convey that data science is not just building the model, it's actually delivering the decision that is guided by the model. So now your question was, how do I do anything? How do I fix any of this?
Yes. When are you deployed? How easy are you to deploy?
Right. So for anybody who's on the engineering side of things, you have probably interacted with NewRelic, which is a one-line install, and then within 5 minutes, you can see your data flowing. Same is true with dcyd. You go to my site. By the way, it's not public right now, so you're not going to find this unless I gave you the link. You would create an account. You'd go over to your line of code where you've actually said predict. You'd put a one-line decorator. Let's say we're working in Python. You put a one-line decorator of that function, redeploy, and now within 5 minutes, you're going to see all of the inputs into your predictions, all of the outputs from those predictions. And that's the quick start. To get more advanced, as long as your code is structured in a reasonably simple way where you've got a distinction between the decision that's being made and the models underneath that are helping you estimate what would happen in order to guide those decisions, you put the decorator there too. And now I'm capturing, again, all the inputs into those decisions, all the inputs into those models underneath, and you go then to your dcyd account, and you can see a nice dependency graph that says, oh, here was the KPI that I was trying to optimize. Here was the decision I was using in order to optimize it. Here are all the models below it that are aiding in that decision. You can double click on any one of those. You can see, oh, it looks like these were the inputs into this decision, so on and so forth. So now, just with a click of a button, a couple lines of code, click of a button, you can see finally what's going on in all your decision making. Hence the company dcyd.
Yeah, well, I think there's a lot of things you said in there that really that landed, and I think from what I'm seeing, not just in this conversation, but what's going on out there, the fact that these things are very easy to install, I think that is going to be the secret.
Yep.
People get called all the time, and no one wants to sit there and do these big installs. When it comes
Absolutely.
When it comes to security, does anything about like the chief security officer, do they have to sign off on this code, or have you been able to
right.
work within
So,
the and have them be comfortable?
Yeah, at this stage, for my customers, we're in an agreement where I'm hosting the data. So the way I do this is it's siphoning the inputs into functions, the outputs from those functions with zero latency, by the way. Everything is done asynchronously. And then it sends it over to my machines, to dcyd's servers, for the analysis. But there's zero reason why when at rest, the data couldn't be sitting exactly on my customers' machines.
That's what I thought.
Because there's so much to do with privacy, GDPR, anonymization. We're totally equipped to do that. It's just not in the product at this moment.
No, that's great. Now, I think the next thing is, you're a CEO of a startup, and as an executive, I thought maybe it'd be nice to hear some advice to data scientists that are introverts, that are maybe too comfortable in this COVID space, home with their headphones. So, any advice that you can share to that population as an executive?
Yeah, I would. It might be the case that saying introverted is redundant when you're talking about data scientists. So the advice I have is for any data scientist, whether or not you feel like you're introverted, it's kind of independent of that. But I would say in the way that data science is evolving, and it should evolve in the next 5 years, is every data scientist should get better at engineering. You should also take broader ownership of what the data science does. So as an example, if you're a data scientist who is super skilled at building a model locally, and you know the ins and outs of every model and how to do the feature selection in the most efficient way, that's great, but you should go outside of that and think, what does it take to get this thing into production and actually moving a needle? To get there, instead of focusing on the most beautiful algorithm, the most beautiful model, think about how am I going to prove to the product team and to the C-suite that my decisions actually moved the needle in the right way. You need to get buy-in from cross-functional teams, or work with your manager. Get your manager to make sure that you've got air covered to work with cross-functional teams make sure that they are on board with what your lever is, which decision you want to make, and what KPI is going to prove that you moved things in the right way. Because without that kind of support, you could build something beautiful, and then nobody has the resources. Nobody wants to commit the resources to getting this thing launched. It takes an engineering, it takes data engineering companionship, it takes engineering companionship, and it takes a product manager who gets buy-in. So thinking outside of data science is one thing. Put yourself in your manager's shoes. That's another thing. It's a good exercise also to think, if I were my manager, what would I be doing differently? And then work with your manager on that, or maybe you're right, maybe you're wrong, maybe you're not comfortable, but you should always be challenging yourself to think about it that way.
Yeah, I got to tell you, sound advice, and I think that's a really good point of view of, we know what I'm good at, we know the superpower, but now let's spend some of this time on other people's calendars to understand how they make their decisions. What are their KPIs? Let me learn their vocabulary, because you're right, let me upskill a little bit wider instead of deep.
Yep.
I love it. So hey, as we wind down, I loved hanging out with you. I want you to have you back, but can you, one more time, give us the website address? And there's a few people I want to have look at this. So I know it's private, but I'll connect you with a few people, and I'll share your LinkedIn profile. But what's the URL again, so everyone listening can check you out?
www.dcyd.io. That's spelled DCYD.io.
Keep an eye out on these guys, and they're going to crush it. So Tim, thanks again for coming on the Data Standard. You can find us, of course, at www.datastandard.io. We'll share the links, and I will connect everybody with Tim. Tim, great seeing you, man. Have a great weekend.
Thank you. Thank you.